You got the marks, that's all I'm doing. Okay, so we're going to finish off the course doing chapters 1, 2, and 3, which are sets and set notation. So there's like 4 sections in here, so we're talking, like a week to get this one done. And this falls under logic and reasoning in the curriculum, and it's part 2 of that because part 1 of that is the puzzles, right? And we'll be doing some of the puzzles coming up as well. Following logic and reasoning, which is chapter 1, we move into chapter 2, which is counting methods or counting, and then chapter 3, which is probability. And that finishes things off. But even when we're doing probability or counting, we're going to have to do this set notation, okay? So the stuff we're doing now is going to carry through for the next few days, or 3 units, right? Stuff we're doing now is going to carry through for the next few units. So we'll still be talking about set notation and sets, even as we go through chapters 2 and 3. Okay, types of sets. So here's a little scenario. Jasmine is studying the provinces and territories of Canada. She has decided to categorize the province and territories using sets. Okay, what's a set? It's a collection of distinguishable objects. What's distinguishable mean? You could tell the difference, right? You could tell them apart, okay? Some objects are indistinguishable, right? If I have 2 of your textbooks, I take 2 of your textbooks, they may be indistinguishable, right? Unless we flip to the back and there's a barcode on, right? So now we can tell them apart. But, so distinguishable objects to be told apart. For example, the set of whole numbers is the set W, which is equal to, and then we use brace brackets. Okay, so that's a brace bracket. You can see this a little clearer if you open your textbook up to 1.1. That's basically all we're doing today is just going through 1.1. So brace bracket, then 0, 1, 2, 3, and dot, dot, dot. What does the dot, dot, dot mean? And on and on and on. What's it called? Ellipsis, the 3 dots, ellipsis, right? It just means it keeps going. So this is the set 0, 1, 2, 3, 4, 5, 6, and so on. How can Jasmine use sets to categorize Canada's regions? List the elements of the universal set. Okay, so there's a lot of definition in this first part, right? So element, an object in a set. For example, 3 is an element of D, the set of digits. Okay, so we're talking digits, that's what's on a numeric keypad, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 is also an element of the set of whole numbers, right? So an element is just an individual object in the set. Of the universal set. Universal set, a set of all the elements under consideration for particular context, also called the sample space. For example, the universal set of digits is the set D is equal to, and then set notation, right? So the brace bracket means set, right? What follows is a set. It's the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's the whole set. Now, in a sense, we've listed the set of whole numbers up here, but we've done it by saying and so on, right? Because you can't actually list that. It's an infinite set. The set of digits is a finite set, right? It has an end, okay? And there's only 10 elements in the set, right? And we'll get to that, the number of elements in that set. One subset of C is the set of Western provinces and territories, W, right? W in set notation. Okay, so W equals, right? And we are going to, so what are the Western provinces and territories? What do we got? Start somewhere. Yeah, that's west. Okay, British Columbia, Alberta, Saskatchewan, Manitoba. Is that a Western province? Yeah. What's the abbreviation for Manitoba? MB. And we need the territories. So we got Yukon, which is YT for Yukon Territory. And we've got the Northwest Territories, which is NT. And we've got Nunavut, which is, I'm not sure what Nunavut is.
It's NU.
NU? Okay, could be NU, could be NV. So I mean, some, some use the first couple of letters. Not Alberta, it doesn't use the first couple of letters, or Saskatchewan. BC just uses an abbreviation of British Columbia, it's the first letter of each word, right? And Manitoba is the first consonant and the last consonant, I guess. So, the Venn diagram to the right. So we're talking about Venn diagrams. Okay, so what's a Venn diagram? It's got a circle, right? And it sets off a set. Represents the universal set C. So the set C is all Canadian provinces and territories, right? So how many elements are there in set C? Let's check out what you're going to do on social studies. How many provinces and territories? 13. Good. Yes. So there are 10 provinces and then 3 territories, right? So there are 13 elements in set C. The circle in the Venn diagram represents the subset W. Right? A subset. Oh, here. Should define subset here. A set whose elements all belong to another set. For example, the set of odd digits, 1, 3, 5, 7, 9, is a subset of D, the set of digits. In set notation, this relationship is written as O. Then you got this thing, it looks like a sideways U, okay? And it's actually on your formula sheet, and it just has a sideways U, and it says is a subset of, okay? So they do give you that. So O is a subset of D. That means that every element in O is also in D, right? So it's a subset, it's a smaller set. The complement of W is the set W prime. So that's read prime. It's an apostrophe, but it's read W prime. And that's the complement. The complement. All the elements of a universal set that do not belong to a subset of it. I thought that was it's kind of blurry. For example, O prime. So the odd numbers are 1, 3, 5, 7, 9. All of the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So O prime is everything that's not in O, right? It's not the odd, so it's the evens, and it's 0, 2, 4, 6, 8. So O prime is the complement of O. A subset of the universal set of digits D, the complement is denoted with a prime sign, right? Which just looks like an apostrophe. Okay, so if you take O and O prime and put them together, you're going to get D. Okay, so if you take a subset and its complement, they cover off everything that's in the universal set. Okay, so describe what W prime contains. So what's in W prime? So W is the western provinces and territories. What's W prime? I'll pause this so that awkward silence for 3 minutes. If W is the set of western provinces and territories, then W prime is the eastern. Okay, so describe what W prime contains. The eastern provinces. Actually, there are no territories in the east, right? We look up here, right? Territories are all west. No territories here. So we just need to list the eastern, right? Or sorry, yeah, eastern. So, or W prime, right? So we could call it the Eastern Territories. We could also call it W prime, right? Not in the West. Okay, now we'll pause. Okay, so write W prime in set notation. So what's W prime? Ontario, Quebec, New Brunswick, Nova Scotia, PEI, what are they, PE? Newfoundland and Labrador. Now what you at? 1, 2, 3, 4, 5, 6. I think that's about it, eh? All right, let's go check. Ontario, Quebec, Nova Scotia. Yeah, okay. Woohoo. Okay, and then end it with a brace bracket, right? W prime. Explain what W prime represents. So in the Venn diagram, where is W prime? Is it inside the red circle, or inside the box but outside the red circle, or is it just outside the box? Yeah, inside the box but outside the circle, right? Jasmine wrote the set of each province as follows: Newfoundland, PEI, Nova Scotia, Brunswick, Quebec, and Ontario. Is E equal to W prime? Yeah. Okay. You're either a Western province / territory or you are an Eastern province. You can't be both, right? There's nobody that's defined as both in the East and the West. List T, the set of territories in Canada. Okay, so T. All right, what were the territories? So we had Yukon and the Northwest and Nunavut, right? Is T a subset of C? Yes or no? Yes. List them. Yes. Is it a subset of W or a subset of W prime? W. Okay. Explain using your Venn diagram. Well, so we haven't even filled in the Venn diagram. Explain why you can represent the set of Canadian provinces south of Mexico by the empty set. What's an empty set? A set with no elements. For example, the set of odd numbers divisible by 2 is the empty set, and it's denoted by, I don't know if those are square brackets. I think those are square brackets, or, gotta find an actual 30-2 formula sheet. They do give you something for the empty set on the formula sheet. And they give you this one here. So for the empty set, they list it like this. Okay, so that's the empty set. There are no elements in that set. Consider set C, W, W prime, and T. List a pair of disjoint. Disjoint, two or more sets having no elements in common. For example, the set of even numbers and the set of odd numbers are disjoint. Okay, so if we're talking about C, W, W prime, and T, what are a pair of disjoint sets? So W and W prime. What else? W prime and T. Okay, any others? Can we put C in there, like C in something else? No, right? Because C is the universal set, so it contains everything, so it can't be disjoint with anything, right? So all that's left would be, well, so can we list W and T? Are they disjoint? Do they have any common elements? Yeah, they do, right? Because T is a subset of W, so they can't be disjoint. Complete your Venn diagram by listing the elements of each subset in the appropriate circle. Because we wanted to list these inside, or we just would put, you know, BC, Alberta, Saskatchewan, Manitoba, Yukon. And if we wanted to list W prime, we would go out here and go Ontario, Quebec, New Brunswick, New Brunswick, Nova Scotia, PEI, and Newfoundland and Labrador. Okay. So then there should be 13 things in here, right? 13 elements. Those things are called elements, right? Members of a set. 6, 7, 8, 9, 10, 11, 12, 13. Woohoo, right? So we've got them all. And we have defined lots of things, right? So let's just run quickly through all of the definitions again. And they're all in your book in the margin. So a set, a collection of distinguishable objects, elements, any object in the set, one of those elements. Universal set is the set of whatever we're talking about. Okay? We're talking about Canadian provinces and territories, then it's a list of all of the Canadian provinces. Subset, a set whose elements all belong to another set. Complement, right? A set, all the elements of a universal set that do not belong to a subset, right? It's got to be all of them. So, if you've listed a set and its complement, you have all of the elements listed, okay? What else? Empty set, a set with no elements, and disjoint, two or more sets having no elements in common. Reflecting. Why might use Venn diagram instead of a map to categorize regions of Canada? So, you're listing them and you just categorize them, right? And so you can see the categories in which you put them. What other sets could you use? So how else could we sort provinces and territories? Come on, she's laughing at you. Come up with something. How else could you sort them? Really? It's like 30 odd people in here. Sure. You can sort them by provinces that border on an ocean and provinces that don't. You can do it by population over and under a certain number. You can do it by land, by the area of land. Right? You can do it by the number of cities they have, right? So you split it into 2 or 3 different regions, right? So there's anything where we can come up with some distinguishing thing, right? Provinces that have oil and gas and provinces that don't have oil and gas. Right? So there's lots of different ways. Communication notation. Following is a summary of notation introduced so far. Sets are defined using brackets. See, these things are called brackets. The round things are called parentheses. For example, to define the universal set of numbers 1, 2, and 3 and list all of its elements. So U is equal to the set consisting of 1, 2, 3. Find the set A that has the number 1 and 2 as elements. A is equal to the set consisting of. So when you see these, just say the set of 1 and 2. All elements of A are also elements of U, so A is a subset of U. The set A prime, the complement of A, is everything that's not A, right? Everything that's in U that isn't A. In this case, 3. And to define the set B, a subset of U that contains the number 4, then we say that B is equal to the empty set. That's more likely the notation you're going to see. Okay, but in the book you might see this notation. Right? And if we're saying it's a subset of U, then we're saying B is a subset of U. Okay? So it's a subset of U, but it's the empty set. So the empty set is a subset of every set. Right? So every set contains the empty set as a subset of itself. Apply the math. Sorting numbers using set notation in a Venn diagram. Indicate the multiples of 5 and 10 from 1 to 100 using set notation. List any subsets. Represent the sets and subsets in a Venn diagram. Okay, so we'll look through their solution. You don't have to write anything down for this, right? Not at this point. So the set S is the universal set is all numbers from 1 to 500, right? 1, 2, 3, ... 498, 499, 500. There are too many numbers to list, right? You can't. You don't want to. You could list them all. You're not going to, though. So we can list it using a different notation, right? So we're saying let S equal the set of all X such that X is between 1 and 500 inclusive, right? Including 1 and 500, and that X is a natural number. So there we're just saying that X is the set of all natural numbers between 1 and 500 inclusive, right? Including 1 and 500. The set that we want, the set F, right? 5, 10, 15, and so on. 490, 495, 500. Again, there's a lot of them. So here we can define it as the set of all f such that f is equal to 5 times x, where x goes from 1 to 100, right? Because 5x would give you 500, right? And so we're getting all the multiples of 5. F is a subset of S, right? All of those multiples of 5 or 10 that are less than 500 are a subset of all the numbers. The set T is all the multiples of 10. 10, 20, 30, 40. Again, there's too many of those. So we go T such that T is equal to 10 times X, where X now goes from 1 to 50, right? Which means that T goes from 10, because you're going to put a 1 in there, and then a 2, and then a 3, up to 500. Then you're going to put a 50. And T is an element of N. T is a subset of F, right? So the multiples of 10 are all multiples of 5, right? Every multiple of 10 is a multiple of 5. It's also a multiple of 5. So that T is a subset of F. And F is a subset of S, which also implies then that T is a subset of S. Right? If T is a subset of F, which is also a subset of S, then T is a subset of S. F prime, the non-multiples of 5 from 1 to 500. Now you can't list them, and it's not easy to come up with a formula type thing, right? You can't just say it's 5 times x, where x goes. So they just did it here, just saying, yeah, okay, I can't use an algebraic expression, I'm just writing a description, right? Showing the relationship. So T is a subset of F. That means everything inside T is also inside F. So the circle T is included within the circle F, right? Now this has stuff like 5. The 10 goes in here. 15 goes there. 20 goes there. 25 goes there. 30, and so on, right? Dot, dot, dot. And then this one will end with 500, and this one will end with 495, right? You keep going, you're going to get up to 495. All of these guys inside F, but not inside, what do we call that one? That's S. All the ones inside the blue circle, oh, that's T, right? Like, oh, I wrote over the T. So all of the ones inside F, but not inside T, will end in a 5. And all of the ones inside T will end in a 0, right? So it's just 10, 20, 30, 40, and so on. F prime, every other number, right? So this is like 1, 2, 3, 4, 6, 7, 9, 11, 12, and so on. Okay? You're never going to write those, right? I mean, you wouldn't write that out. Since T is a subset of F, the circle that represents a subset T is inside the circle, right? Every element fits inside. Your turn. Indicate the multiples of 4 and 12 from 1 to 240 inclusive. Yeah, forget that. Determining the number of elements in a set. Okay, so we have a set. The number of elements in the set C for the provinces and territories was 13. Right? So we just look at the map, we count off, and say, I got 10 provinces, 3 territories. There are 13 elements in that set. The number of elements in the set W, which was Western Canada, Western Canadian provinces and territories. It was BC, Alberta, Saskatchewan, Manitoba, and the 3 territories. So there were 7 elements inside that set, right? The number of. So here it's saying a triangular number, 1, 3, 6, 10, and so on, can be represented as a triangular array, right? You can make a triangle out of it, and so on. Determine a pattern you can use to determine any triangular number. Determine how many natural numbers from 1 to 100 are even and triangular, odd and triangular, and not triangular, and how many numbers are triangular. All right, so Simon says, examine the pattern of dots for the triangular numbers 1, 3, 6, and 10 to find the pattern. So he said, well, how do I get from here to here? I put 2 dots down. Now, if I've got this, then I need to put 3 dots down. And if I've got this pattern, which is here, 6, then I need to add 1 more dot. So how many will be in the next? So you're going to add 5, right? So this is 1 plus 2 gives you 3. Plus 3 gives you 6, plus 4 gives you 10, plus 5 gives you 15, plus 6 gives you 20, and so on, right? So that's how the pattern. So that's what he's looking for, is what's the pattern. The nth triangular number is the sum of the first n natural numbers, right? Okay, so if we look, the first triangular number is 1. The second one is 1 plus 2. The third one is 1 plus 2 plus 3. The fourth one is 1 plus 2 plus 3 plus 4, right? So the nth one is 1 plus 2 plus 3 up to n. I used a spreadsheet to generate more triangular numbers, right? He's got a spreadsheet, we don't, right? Just added, just said, make sure you're going to add 2. So got the natural numbers to take this plus this, and then add this, and so on, right? To generate the numbers. And you do that till you get to 100, right? Well, in this case, you do it till you get past 100, and you say, all right, well, this isn't part of it, right? I need to go up to here. The phrase from 1 to 5 means 1 to 5 inclusive. In set notation, the number of elements of the set X is written as nx. So if we say the numbers from 1 to 5, we are including the 1 and including the 5, right? Because sometimes this can come into doubt, right? And sometimes there's questions that come up on the exam that we discuss before the exam gets to you guys, and we say, well, wait a second, let's make sure the wording is clear so they'll know. Okay. But they're saying here, you say from 1 to 5, you're including the 1, you're including the 5, right? So if I say the marks on, the quizzes you wrote yesterday were from 0 to 4, right? That includes the 0 and that includes the 4. For example, the set X is defined as set numbers from 1 to 5. X is 1, 2, 3, 4, 5. The number of X, so this n bracket X, number of elements in set X, and these guys are parentheses, is 5. So Simon's gone through and he says, okay, universal set is natural numbers from 1 to 100, right? We're looking for the triangular numbers. T is the triangular numbers from 1 to 100, okay? So he's just pulling that out of here. These guys are the triangular numbers. So there's the set T. Even triangular numbers is going to be a subset of T, right? Because if you're an even triangular number, then above all else, you are a triangular number. So we just look through this list and pull out the even, right? 6, 10, 28, 36, 66, 78. Okay, so that's all I did, right? So we know that E has to be a subset of T. The number in T, so you just count them, right? Or you just go to the table and you just say, well, okay, wait, 1 to 13, right? So there are 13 triangular numbers. The number of even ones is 6. The number of odd ones, well, you're either even or odd, right? You can't be both. So really, O is the complement of E, right? I could say O, I could say E prime. They'll both say the same thing. So the number in O is the number in T minus the number in E, 13 minus 6, or 7. So there are 7 odd triangular numbers. The number of numbers in the universal set is 100, right? Because we're taking all the numbers from 1 to 100 and saying, who of you are triangular? And then who amongst you are even, right? And how many? So if we know there are 100 numbers and 13 of them are triangular, then there are 87 non-triangular numbers, right? And we represent that by T prime, numbers that are not triangular. There are an infinite number of natural numbers, so there must be an infinite number of triangular numbers, right? I mean, you can always find another triangular number, you just have to add another number on. The set of triangular numbers is an infinite set, okay, like the set of whole numbers, right? 0, 1, 2, 3, goes on forever. So an infinite set, a set with an infinite number of elements, for example, a set of natural numbers, the counting numbers, right? 1, 2, 3, so on, is infinite. Explain why Simon defined O as a separate subset rather than using E prime. Could have done either, right? O is just more evocative, right? I mean, E even, O odd. Wait, skip something. Yes, describing the relations between sets. Alden and Connie rescue homeless animals and advertise in the local newspaper to find homes for the animals, blah, blah, blah. You can read, right? Setting up a web page. So they want to organize the animal. They have dogs, cats, rabbits, ferrets, parrots, lovebirds, macaws, iguanas, and snakes. So the only ones that rhymes are ferrets and parrots. So if we're doing rhyming ones, then ferrets and parrots will go together, and the rest. But that's not how we're going to categorize our animals, right? So design a way to categorize. So let's just look at the way that they did, right? And remember, there's more than one way, right? Provinces, eastern provinces, western provinces, provinces that border an ocean, provinces that don't, provinces with a population above whatever, 1 million, and provinces with a population less than 1 million. So define the universal set. A is all the animals that are available, and they split it into warm-blooded animals and cold-blooded animals. Listed the animals in each subset, right? So dogs, cats, rabbits, parrots, lovebirds, and macaws are all warm-blooded, and the iguanas and snakes are cold-blooded. Decided to organize the subset of warm-blooded, right? Because warm-blooded, it's got a lot in there, so we can split them into sets. This one is mammals, dogs, cats, rabbits, and ferrets, and this is birds, parrots, lovebirds, and macaws. Right? So again, so we can split a set into a subset, but that means that M and B must be inside W, right? So if we're going to do a circle for W, we have to put M and B as separate circles, right? There's no overlap. As separate circles inside the circle W. Okay, and there they are, right? So here's W, this is the warm-blooded mammals. Here's M, this is mammals. Here's B for birds. And here's C for the cold-blooded animals, which are the iguanas and the snakes, right? So I drew circles to represent them. M and B had to be inside of W. M and B had to be disjoint sets because they share no common, right? There are no birds which are also mammals. There might be mammals who can fly somewhat, but the disjoint sets, so disjoint sets, just ones that have no joint. So W and C are disjoint, M and B are disjoint. Look for subsets. So M is a subset of W. M is also a subset of A, right? All of these guys are subsets of A, right? C is a subset of A. B is a subset of A. M is a subset of A. M is a subset of W. B is a subset of W. C is only a subset of A. It's not a subset of any of the other guys, right? So that's all put down here. If it's a subset of, then it's got to be included in, right? Like enclosed by, like fully enclosed. And how else? Then we got F is fur-bearing animals. So we've got cats, dogs, ferrets, and rabbits. And M is equal to F. So the mammals are fur-bearing mammals by definition. Mammal has hair and all that good stuff. Live births and such. Solving a problem using a Venn. Okay. Anyway, so that's that, right? Just an analysis of what's going on with that and how you can categorize. Solving a problem. Buyana recorded the possible sums that occur when you roll 2 4-sided dice in an outcome table. Okay, so if you think about it, I've got here like a, I don't know, is that blue? Call that blue and red. I've got a blue die and a red die, right? And they go from 1 to 4, right? So they're shaped like a pyramid. So they've got 4 sides, right? A triangular-based pyramid, not a square-based pyramid. So it's shaped like a pyramid. And they have the numbers 1 through 4. So if you get a 1 on the blue and a 1 on the red, you've got a sum of 2. 1 on the blue and a 2 on the red, you got a sum of 3 and so on. So you can go from a sum of 2 up to a sum of 8. If you are rolling 2 normal 6-sided die, then you go from 2 to what? What's the highest you can get on a pair of dice?
6.
The highest sum you can get on a pair of dice?
12.
12, right? The highest you can get on a die is 6, but on a pair of dice, you get 12, right? These are 4-sided dice, so they only go to 8. Display the following sets in one Venn diagram. Rolls that produce a sum less than 5. Okay, let's see what they do here, how they define a roll. Okay. So if we're looking at a roll that produces a sum less than 5, 1 and 1 gives you a sum less than 5. 1 and 2, 1 and 3, 2 and 1, 2 and 2, 3 and 1, and that's it, right? So here are the sums that are less than 5, and here's how you get them, right? You do one of these, one of these, one of these, this and this, this and this, and so on. So that's how they're categorizing it, right? So let's go and look at it. Represented relationship as Venn diagram. So less than 5, a 1 and a 1, a 1 and a 2, a 1 and a 3, a 2 and a 1, a 2 and a 2, a 3 and a 1. That's it. Greater than 5, a 2, a 4, a 3, a 3, a 3, a 4, a 4, a 2. So what's left out of this diagram? 5s, right? So we'd have to list the 5s, right? So this is all everything less than 5. This is a sum of 2 or 3 or 4, and this is a sum of 6 or 7 or 8. Okay, so then what's left? that you'd have to list. So like we have a 1 and a 4. We'd have a 2 and a 3. We'd have a 3 and a 2. And we'd have a 4 and a 1. Okay, and that's what's left, right? So there's a total of, looking back here, there's a total of 16 possible rolls, right? 1, 2, 3, 4, 5, 6, 7, 8. So there's 16 possible outcomes, right? Or rolls. Okay, so you get 16 possibilities. And so if we count these up, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right, so we would know there'd be 4 that have to be outside of that circle. Now, oh, big definition here. This one. This actually comes in a lot more later, like in counting in chapter 2, but it's defined now. Since we're talking about sums that are less than 5 or greater than 5, you can't have a sum that is both, right? Either it's less than 5, or it's greater than 5, or it is 5. Those are the possibilities. So it says a number can't belong to both of these sets, right? It's in one set or the other. If sets are disjoint, the events that describe these subsets are mutually exclusive. Mutually exclusive. 2 or more events that cannot occur at the same time. For example, the sun rising and the sun setting are mutually exclusive, right? It's doing one or the other, right? It's either raining or it's not raining, right? It's sunny or it's not sunny. Those are mutually exclusive events. So in this case, you get less than 5 or you can get greater than 5. You can't get both at the same time. Count the number of elements in each set using the outcome table, right? So 6 there is 12. Number of ways these events can happen. So how many ways can you get a sum that is either less than 5 or greater than 5? You just have to add them up, right? Less than 5 or greater than, it's the number of ways you can get less than plus the number of ways you can get greater than, right? Which is 6 plus 6 or 12. Okay, and we will be going into a lot more detail on mutually exclusive as we work our way through the sets. A sum that is greater than 5 or less than 5 can occur in only 12 ways. There are 4 ways that either sum cannot happen, right? And there are 16 possibilities. So there's 4 other possibilities we already discussed, right? Which is you got to get a 5. Your turn. We'll have enough stuff to do. Summary. You can represent a set of elements by listing the elements. So A is equal to, we use set notation. That's a brace bracket, right? 1 to the right, brace bracket. Using a word or sentences. So A, all integers greater than 0 and less than 6. Okay? So greater than 0, less than 6. We'd also say from 1 to 5, right? So we're saying from 1 to 5, we're including both ends, right? Here, we're saying greater than 0, so you don't include 0. We're saying less than 6, you don't include 6. You can define it this way, right? And x belongs to the integers. You could also define it, set x such that 1, so x is between 1 and 5, and x belongs to the integers, right? Or the natural numbers, wouldn't matter. But this would include the 1 and include the 5. Right, so when we say from 1 to 5, this is what we mean, from 1 to 5. And here we're saying greater than 0, less than 6. So in these next few chapters, there's a lot of interpretation of the English language, right? It's like reading something and say, okay, what's actually included there, right? So a lot of times, when you read a problem, you might actually want to write down the numbers. Just say, all right, look, this is going to include 2, 3, 4, 5, 6, or something like that, right? When you sit down to do a question on the diploma, you might want to sit down and list all the numbers in the subset, right? It's not going to be like 1,000 of them, maybe 10. You might want to write all 10 of them down, just so you've got them staring you in the face, and you can use that when you go to do the question. You can show how sets and subsets are related using Venn diagrams. Venn diagrams do not usually show the relative sizes of the sets, right? So we don't make a big circle because it's got a lot of stuff in it, and a little circle. We generally tend to make the circles the same size. Okay, and we talk about the number of elements. You can often separate a universal set into subsets in more than one correct way. I mean, unless the question says do it this way, then there's only one correct way. But if I just say split it into subsets. Need to know, sets are equal if they contain exactly the same elements. Okay, so if they're equal sets, everything, they got to be exactly identical. Even if the elements are listed in different orders. So for example, the set 1, 2, 3 and the set 3, 2, 1 are equal sets. You may not be able to count all the elements in a very large or infinite set. Well, very large could be difficult to count, and an infinite set could be impossible to count because it's infinite, such as the set of real numbers. The sum of the number of elements in a set and its complement is equal to the number of elements in the universal set. Okay, so n bracket a bracket, sorry, parentheses, n open parenthesis a close parenthesis, the number of elements in set A, the number of elements that are not in set A is equal to the total number of elements in the universal set, right? So everything's included, there's nothing left out, right? So these guys back here, these are not complements, right? They're not complements. We said if we stuck these guys inside here and said it was a sum 5 or less, then these guys would be complements, right? That would be the sum 5 or greater. Okay? So they're not complements because they don't contain. They only had 12 out of the 16 elements. When two sets are disjoint, then if you want the number in one set or the other, you just add how many are in one and how many are in the other. Okay? Doing a lot of that stuff. This comes into probability, right? So here's the deal. Anytime you see like this n, you can replace it with a p for the probability. And anytime, because they're going to give you these probability formulas, if you want to work out the number of, basically instead of saying probability, just say the number of. Okay, you can replace any of these p's with a little n, and the formulas are still going to hold. Okay? So it's kind of handy that way, because they don't give you any formulas for numbers or for working with the numbers, but they're all here just written with the probability. And that's it.